we are looking at this example. We're looking at this example from section 5.5, and give me a thumbs up if everybody's seeing that okay. Again, thank you, thank you. And okay, we're going to make the substitution then, u equals 7x. Give me a thumbs up if you see me circling u equals 7x. The circles are where they should be. Excellent. Thank you. Thank you. Thank you. So, Samuel, maybe just, I don't know, log back in. Okay, you're good. Good. Okay. Remember, everybody, there's a feature on the right. I'm told you all, as students, have a thing that will zoom the screen to make it look a little bigger for you. Okay. So, okay, so we end up then with this new integral. So again, my reason for letting u equal 7x is I'm used to problems where I just have like the arc sine of x. Arc sine of 7x, makes me feel a little uncomfortable. I would like to have the arc sine of just a variable without a number in there. So that's why I let u equal 7x. And when I do that, this integral becomes now this new integral with respect to u. So I'm converting the integral with respect to x to an integral with respect to u. And that's what I have here. So the x limits of 1/14 and 0 become 1/2 and 0 because u equals 7x. So 7 times a 14th is a half, and 7 times 0 is 0. And of course, I can factor the 1/7 out in front. So this is what my integral now looks like. And you know, even though I don't have the answer yet, it just looks like a nicer integral to work with. So I'm just saying, you can do that if you want. Okay, but now we have to think about a substitution. We have to think about a substitution. Now, I'm going to let my substitution variable be w, just because I've already used the variable u in the problem. So, you know, substitution, I can use the variable w. I have to decide what I'm going to let w equal. So what's kind of the hard part in the problem? What's kind of the difficult part of the problem? If you look at the integrand here.
The square root.
Well, Maria, the square root's difficult, but we're going to use it to help us. We're actually going to let w equal the arc sine. We're going to let w equal the arc sine of u. And I'll show you why this works. May I go to the next page? Does everybody have this copied okay? Okay, excellent, excellent. Okay, to the next page then. So what I do, very good, Ryan, excellent. Okay. What I do is I write the integrand. I'm choosing to write it as a product here of 1 over the square root of 1 minus u squared times the arc sine of u. Because then when I let w equal the arc sine of u, you can just see that it works better. So the arc sine of u is now w. And I have to then replace that 1 over the square root of 1 minus u squared and du. I've got to replace that with functions of w. Well, how many remember that the derivative of the arc sine is 1 over the square root of 1 minus u squared? How many remember that from their calculus days? Okay, Jacob does. Excellent. And okay, so well, that means then that dw is equal to 1 over the square root of 1 minus u squared du. And so now I've accounted for the rest of the integral here. Okay, and so the integral then is simply going to equal, it's going to equal the integral of w dw. And of course, I have new limits now. I have w limits. Okay, the w limits, since w is equal to the arc sine of u, my new limits are going to be the arc sine of a half and arc sine of a 0. Are there any questions up to here? Okay. Well, of course, now we have to rely on our trigonometry knowledge. Okay, we have to rely on our trigonometry knowledge. I have to go back to the trig days. So what's the arc, like the arc sine of a half? What's the arc sine of a half? Well, all right, let's see. So the arc sine of a half means tell me the angle whose sine is equal to a half. That's what that means. So I drew a 30, 60, 90 right degree triangle. Okay. How many of remember seeing this in trig? Yeah, definitely. It's one of those common triangles. And the sine of 30 degrees, well, sine is opposite over hypotenuse. The hypotenuse here is 2, and 1 is going to be, if I pick the 30 degree angle, then the sine of 30 degrees, or pi over 6, is a half. So that means pi over 6 is the arc sine of negative a half, and so that's why I have pi over 6 here. Okay, similarly, the arc sine of 0 is just going to be 0, right? Because the sine of 0 is equal to 0, so the arc sine of 0 equals 0. And so now this integral that we started with, okay, this integral that we started with is becoming much nicer. Now it's a calculus 1 problem. Okay. Are there any questions so far? Okay. May I move to the next page? Okay. Okay. We'll go to the next page here. Very good. Here's my integral. And you notice sometimes what happens is students, they like to go back to the previous variables, but you don't need to. You know, we're working with variable w now, and these are my w limits right here, pi 0 and pi over 6. So I'm just going to proceed forward and integrate this. I mean, and if I do, I'm going to get pi squared over 504. Let me give you a moment to copy that down. Okay. Okay, and WebAssign now. So I believe you are going to have a problem like this in those in that second batch of 5.5 exercises due on Saturday. And WebAssign wants the exact answer in simplified radical form. Okay, WebAssign will tell you when it wants a decimal. Okay, it will traditionally tell you, because it'll say like round your answer to the nearest tenth or hundredth, something like that. I mean, you know, this is like, you know, God's answer, so to speak. This is the best answer possible. I mean, no decimal is going to equal that answer. That is the best answer possible. Okay, so then are there any questions? Okay, and then this is then the final answer. I'm pleased we have, looks like we have full attendance tonight. It's excellent. This is, you know, it's very important to attend your summer classes, to attend this class. Oh, Nathan, there's no constant because this is a definite integral. You have upper and lower limits. So there's no, you know, there's just no, I mean, what you're doing is you're finding the area underneath the curve, underneath this function here, this function. Hold on. This function here, this function f of x, if you were to graph that function, okay, graph it from x equals 0 to x equals 1/14th, and evaluate the area between that function and the x-axis, you would get pi squared over 4. Obviously a very small area, because, you know, okay, you're welcome. All right, are there any questions on this? If not, we'll move on to where I think 5.5, that substitution section, we've covered it pretty well. Section 5.6, integration by parts, we need to do a few more examples there. So, all right, well, if you're good with that, then let's proceed on. Let me stop the recording here.